Hello everyone, I'm Anisha. Welcome all of you to my channel, that is virtual classes. So today in this class we are going to continue your chapter number 4 that we have already started, that is exploring magnets. Okay, this is your class 6 science book Curiosity. Alright, and if you haven't watched the first part, kindly watch the first part. The link is given in the description box, and today this explanation will be completely in English. If you want to listen to Hindi explanation, you can find the link again in the description box. And yes, don't forget to like, share and subscribe my channel. So now let us start. See, today's topic is attraction and repulsion between magnet. Okay, we are going to understand the attraction and repulsion between these magnets. See, in our previous class there was one question left, isn't it? It was been raised, and I have told you that we will learn in our next class. That is, the question was, what happens when we bring two magnets closer to each other? So we are going to learn about this today, okay, in this class. When we bring two magnets closer together, what will happen? Okay, and which poles attract each other and which poles repels each other. We are also going to understand the that fact. Okay, so now let us experiment. Take a pair of bar magnets on which north and south pole have been marked. Mark the two bar magnets as A and B. So first you need to take two bar magnets on which north and south poles have been marked, okay, and you have to take two bar magnet and again mark them as A and B. We will understand, we'll go through the image and we'll try to understand. All right, place the longer side of the magnet A over 5-6 round pencil as shown in figure 4.88, like this. Okay, you have to place longer side of the magnet A, okay, around some 5 to 6 round pencil, like just like which is shown here in this image. Now bring one end of the magnet B near the end of the magnet A placed on the pencil. Make sure that the two magnets do not touch each other. Observe what happens. So what happens? See, when you see, let us see this image and let us try to understand. Okay, see, this is the magnet A and this is the magnet B. Okay, in magnet A you have to place some round pencils around it, okay, below it, and you have to bring one magnet near them. And see, and this we have to do in two ways. Okay, first, what difference is there? First you will be seeing the different poles. Here this is south poles and here this is north pole, and here it is the same pole, south pole and south pole. Okay, so after doing the so during this experiment, okay, what will you observe when you bring a bar magnet which is opposite pole, with opposite pole, north pole? Okay, and what will happen, what will you observe when you bring a bar magnet with the same pole, that is south pole, south pole? See, in case of this north pole, in case of this opposite poles, this is south pole and this is north pole, isn't it? These will attract each other. Okay, and when you bring closer the magnets, this will come closer, this will attract each other. Okay, this will attract each other. And here in this case, when you are keeping the same direction, okay, same pole, that is south pole here and south pole, what will happen? This will repel, this will go away. Okay, in the case of opposite direction, it will attract each other, and in the case of same pole, okay, like poles, it will repel each other. That means it will move away. All right, so here next, bring the other end of the magnet B near the same end of the magnet A. This experiment which I have already explained you. Okay, thus the magnet A on the pencil begin to move, yet it will move. Okay, does it always move in the direction of the opposing magnets? What do these observations suggest? So see, if there is a like pole, then it will move away. Okay, and if it is an unlike pole, that is with opposite sides, okay, opposite directions, opposite that is one is south and another is north, it will attract each other, it will move closer. Okay, so this is the experiment. I hope you have understood, and we will understand this experiment more. Okay, you will see the unlike. So this is important, kindly remember this fact. Okay, unlike poles of two magnets, that is the north pole of one magnet and south pole of another magnet, attract each other. So when you bring closer two magnets, okay, that is that unlike poles, in one side there will be one direction, there will be north pole, and in that same direction if you bring that south pole, what will happen? You will observe that they are trying to attract each other. Okay, and the like poles, that is either of the north poles or the south poles of both magnets, repel each other. And if you bring the like poles together, that is north pole and south pole, like this. See here, this is the two bar magnet here. Okay, just imagine this is a two bar magnet, and here this is the north and this is the south. Okay, here this is south and this is north. What happens? See, both south are here, isn't it? The south pole is here in this case also, and in this magnet also south pole is here. So what will happen in this case? This will repel each other. That means it will move away with one another. And in case if you bring two magnets again, okay, just like this, Here this is north pole, and here this is south pole, and here this is south, and here this is north. And in this case what will happen, these two will attract with each other. That means opposite poles attract with each other, and similar poles, that is like poles, repel with each other. Okay, this is the concept. I hope you are clear. So we will understand more. Again, we are again going to do the same activity, but using this time one iron bar. In place of magnet bar, we'll use one as iron bar. One will use iron bar and another will use magnet. Okay, magnet bar. That is, repeat the activity by using an iron bar in place of one of the magnet. What do you observe this time? So what will you observe? You will find that both the ends of the iron bar will be attracted by both the north and south pole of the magnet. From this activity, we find that a magnet can be identified by its property of repulsion. So now, in place of one iron bar, okay, in place of one magnet bar, you will replace it with iron bar. At that time, what will happen? Even if you bring the like poles or unlike pole in any poles, okay, what you will find, the iron bar will always be attracted, okay, by both the north pole as well as the south pole. So from this activity, what we can conclude? We can conclude that we can identify magnet. Okay, we can identify this magnet by its property of repulsion. In case if we use both two magnets, then what happen? Two magnet bars, then what happen? Opposite pole will attract each other, and same pole will repel each other. Okay, that is, unlike pole attract each other and like pole repel each other. So this is the concept. Okay, again let us find out more about this. Okay, here again the question has been raised by this girl. The compass needle is also a magnet. See, we have learned about our compass needle in our previous class, isn't it? So the compass needle is also a magnet. So will it show the same behavior if a magnet is brought closer to it? So is it going to show the same behavior if we bring a magnet closer to it? Just like the above activity. Okay, here we are going to use a compass, a magnetic compass and a magnet bar. Okay, so let us experiment this. Take a magnetic compass and a bar magnet. Place the magnetic compass over a horizontal surface and wait for its needle to come to rest. So now what you need to do? You need to take one magnetic compass and a bar magnet, okay, and place that magnetic compass in a horizontal surface and wait till its needle came to rest. Okay, when the needle comes to rest, it means if the needle is not moving. Okay, when the needle is not moving. So now what will happen? Now slowly bring the north pole of the bar magnet closer to the north pole of the compass needle as shown in figure 4.8. We'll see by the image also. Okay, so now what happens? See here, first image. Okay, this is the first image. Now what we are doing? See, this is the north pole here, isn't it? And this is the magnetic compass. So here it is the north here, isn't it? And here it is the south. Okay, so when we bring this closer, this north pole here, okay, this magnetic bar with the north pole, okay, north pole. So what happened? When we bring this close, this needle, see, first it was there, okay, it was resting here like this in this position. Okay, now what happens? It moved away. It moved away. That means it repelled. Because this is also north pole of a magnet and this needle is also magnet, and when it was here before, it moved away to here. Okay, why? Because it is going away, it is repelling, it is deflecting. Okay, I hope this is clear. Again, observe the compass needle carefully. So we have already done, isn't it? I hope it is clear. So what do you observe? Does the needle deflect? If yes, which direction? See, what do we observe? We observe that the needle is deflected. That means it went away, it ran away from this position to this position. Why? Because same pole repel each other. This is what we have just done in our previous just now in our previous activity, isn't it? Previous experiment. So now again we are going to repeat this same thing with opposite direction now. Okay, now repeat the above step with the south pole of the bar magnet. So now this south pole, it is here, isn't it, near the compass. Do you observe any difference this time? So yes, we observed this difference. And what is the difference? See, the needle, actually the needle is like this. Okay, when it rests, it will come in this way. Okay, in this position. Now when you are bringing this south pole here, okay, south pole of this magnet bar closer to this compass, not touching it, okay, closer, what will happen? This needle from here, it will move towards here. That means it is attracting, coming closer, isn't it? Here it is running away because it is a like pole, and unlike pole here, opposite poles, it is attracting each other. So this is the concept. Okay, I hope this is clear. What you need to remember? Opposite poles attract each other and same poles repel with each other. Or just like in your book is written, unlike pole attract each other and like pole repel each other. Okay, So this is the concept that you need to understand. So this is what it is given here. Okay, again this is important. When the north pole of a magnet is brought closer to the north pole of the compass needle, it moves away, as shown in figure 4.9a, as I have already shown you, isn't it? And I hope this is already clear. So, and when the south pole of the magnet is brought closer to the north pole of the compass needle, what does it happen? It moves closer. So that is what we have just observed, isn't it? So now let us again repeat that experiment with by placing a wood. Okay, this is what this girl is raising here. Okay, suppose we place a piece of wood between the compass needle and the magnet. What will this affect the direction of the compass needle? So we are going to check whether it will affect the direction of the compass needle or not if a wood is kept in between them. Okay, here in this position, as it is shown here in this image. This is the magnetic compass and this is the magnetic bar, and here perpendicularly what we have done, we have placed a wood. Okay, so now repeat the first or second part of the activity. We can repeat any of the part. Okay, by keeping the south pole and again by keeping the north pole. Okay, so here in your diagram they have given the south pole. So now let us see about south pole. Okay, so without disturbing the bar, magnet and magnetic compass, place the piece of wood between them perpendicular to the table as shown in figure 4.10. Observe the compass needle carefully. So now just like this, okay, you have to place this or the wooden bar, okay, wooden bar in between this. So first, when you bring south pole towards the compass needle, what will happen? It will attract, see, just like here. Before its position was like this, but now it is attracting. That means it is attracting. That means even if you place a wooden wood in between these magnetic bar and these magnetic compass, the magnetic effect pass through the wood. Okay, the magnetic pass is same, okay, as it is before when we just done the experiment without keeping any wood in between. Okay, so this is the case. So is there any effect on the deflection of compass needle due to piece of wood? No. Okay, there is no deflection. The compass and the magnetic compass and the magnet bar will show the same direction, just it will be same as just before we have done the experiment. If a north pole, suppose here, if we bring this north pole here, okay, if this north pole is bringing here, then if we bring this north pole here, then what will happen? Again this compass will move like this towards this way. Okay, this way. That means it will run away. That means it will repel, because like pole repel with each other. Okay, so this is the experiment. I hope this is clear. So repeat again this process, okay, by replacing the piece of wood with a cardboard sheet, thin plastic sheet and a thin glass sheet. So even if you repeat this same experiment, okay, same process by replacing the wood with a piece of a cardboard sheet or thin plastic sheets or glass sheets, what will happen? You will find no change. Why? Because the magnetic effect passes through the wood, it will pass through the cardboard, or it will pass through the plastic, and it will also pass through the glass. Okay, there will be no change. I hope this is clear. That means even if you keep anything in between a bar magnet and a magnetic compass, what will happen? The movement of the needle will be same. Okay, there will be no change. Okay, I hope this is clear. So what you have to record here in this table? Observing the effect of magnet through non-magnetic material. See, we have placed a non-magnetic material in between, isn't it? Wood is a non-magnetic material, cardboard is a non-magnetic material, plastic, glass, isn't it? These are all what? Non-magnetic material. That means if you put a non-magnetic materials in between, you will find no change. So what will be your observation? No change in all the cases. Okay, there will be no change. The compass needle, the magnetic needle will move as it will move, even if there is nothing between it. Okay, so everything, this is all same, no change, no change, no change. If you want to write the explanation here, you can write magnetic effect passes through wood, and here magnetic effect passes through cardboard, and here magnetic effect passes through plastic, and here magnetic effect passes through glass. So we are also going to perform the same thing, and we are also going to have some fun with magnets now. Okay, so what do we conclude? What do you conclude? See, this is again important. Okay, do you remember this one? You would observe that there is no appreciable change in the deflection of the needle when a sheet of any of the above material is placed between the magnet and the compass needle. So there will be no change even if you keep anything in between. Anything means non-magnetic materials. Okay, if it is a non-magnetic materials, then there will be no change. Okay, deflection here means the movement. Okay, Therefore, we can conclude that the magnetic effect can act through non-magnetic materials. So, with this experiment, what we can conclude? We can conclude that the magnetic effect, okay, it can act through, that is, it can pass through, okay, through non-magnetic materials. So, now let us have some fun with magnets, okay. After learning about magnets, Reshma was excited and decided to set up some fun activities using magnets at her school fair. So, it was Reshma who find it about magnets, isn't it, while she was writing her short story. Now, after learning so many things about magnets, now Reshma was very excited, okay, and she decided to set up some fun activities using these magnets in her school fair. And she have shown, okay. So, now we can also try. You may try making these yourself and may also think of some of more fun ideas. So, some of the ideas are given here. If more ideas comes into your mind, you can do, okay, you can play with it. So, here magnets can move some objects without touching them. Is that not amazing? See, magnets, we will experiment this here, okay. See how magnets can move some object without even touching them. Here, see, in this case of this magnetic garland, it looks just like a garland here, isn't it? And this is the south pole, this is north pole. Here, see, keeping a magnetic bar and placing some thumb pins, okay, thumb pins, what you can do, you can make a magnetic garland without touching the thumb pins, okay. See, and what one more thing that you observe here, what that we have learned before is that, see, here in these poles, okay, in the ending part, okay, here in south pole as well as north pole, more pins are being attracted, and here few. Why? Because this part has weaker magnetic effect and this part is stronger. It has stronger magnetic effect as compared to the middle part that we have already learned in our previous class, isn't it? So, this is why we can get the result, okay. So, next, what activity can we do? See, okay, we can do with this in this game board. Can we take the steel balls out of the maze by moving a magnet below the cardboard tray? Yes, see, in this game, okay, you can move these steel balls, okay, when you are moving a magnet below this cardboard, okay, this steel will be moving and you can take out this easily, okay, because see what we have just learned before in our experiment, magnetic effect can pass through wood, cardboard sheets, paper, glass, plastic, isn't it, anything. So, can we pick out a steel paper clip fallen in water using a magnet without getting our fingers or magnet wet? So, next thing what we can do, see here, if this is a paper clip, okay, this is a steel, and yes, remember the things that you are going to move should be all metal, should be they should have a magnetic properties, okay, that is they should be attracted by magnets. Otherwise, if you are doing this with like wood or pencil or plastic, it will not move, okay. Only if when you are doing these things, this experiment, these fun things with those things which magnet can move, in which it has been attracted by magnet. Here, like steel ball, it is attracted by magnet, isn't it? And this is also again steel paper clip. This is why it is mentioned here, steel paper clip, okay. So, suppose in a glass of water, this steel paper clip is fallen down here, it was here before, okay. So, what you can do without getting your hand wet and without making the magnet wet, what you can do, you can just move this one. Before it was here, and when you are moving the magnet, bar magnet from here to here, it is coming up here, again it will come up here, and you can take it out. So, this is amazing, isn't it? You can try it out, okay, if you have magnets at your homes. And one more thing here, another, will the two cars speed towards each other or run away from each other when brought closer? So, here we have two cars and two cars match of the two matchbox, okay, which is made up of two matchbox, and we have a magnet placed in it, okay, and with this like pole, okay, like pole, that is here, this is north pole, okay. Sometimes in some magnets you will find that the north pole is been indicated by white dot, about which you will learn here, okay. So, this is the north pole, this is north pole, and this is also north pole, and this is the south pole. So, what will happen in this case? What we have just learned, we learned that same poles means same poles, like poles repel, that is it will run away from each other, isn't it? This will run away from here. So, and this is also will try to go away. And if in case here it was south and here it was north, then what will happen? It will attract each other, okay, it will attract each other, this will come closer. But here in this case, as it is a like pole, what will happen? It will go away, this will go away, and this will also go away in another direction, okay. So, I hope this is clear. So, now let us see some more things about magnets. in some magnets, the north and south pole are marked as N and S. Okay, in some magnets you will find that the north pole and south poles are simply marked by writing N and S, north for N and south for S. Okay, and again in some other magnets you will find that the north pole is indicated by a white dot, just like this before in this image what we have shown. Okay, and sometimes the north pole of a magnet is painted red and south pole is painted blue, and sometimes what we will find, the north pole is been painted red, as in the case of that magnetic compass. We found that the north pole was painted with the red, isn't it? So, and in some magnet what you will find, the south pole is painted in blue. Okay, if the north pole is painted in red, then the south pole will be painted in blue. Okay, this was just an extra information. All right. So, and yes, this is we have come towards the end of your chapter. Here some steps are being given how you can keep your magnet safe. Okay, how to keep the magnet safe. Magnet says here, store me properly, keep me in pairs with unlike poles on the same sides, keep a piece of wood in between, place 2 pieces of soft iron across the end. So this is how you have to keep a magnet. See, just like this it is shown in the image, you have to keep the unlike poles, not like poles. Okay, unlike poles, opposite poles, and in between you have to keep one wood, and inside you have to keep one small iron piece. In this way you should be storing magnet, you should be keeping magnets at your homes. Okay, you cannot just throw magnets here and there. Why? Say, and do not hit me or drop me or hammer me, and you should never hit magnet, or you should not never drop magnet down, or you should not hammer it. Why? Because its magnetic effect will be slow. Okay, your magnetic effect will not be strong, it will be slow. And here, do not keep me near mobile phones or remote control, and you should never keep magnets near your mobile phones or remote controls. That means you should always keep magnets very safely, just like this it is given, like in the between you should keep one wooden, okay, small wood, and unlike poles you have to keep unlike poles, north with south and south with this north. Okay, and you have to keep one iron piece, a small iron piece. So this is the correct way of keeping magnets. And here one question is there, have fun but treat magnets with care. So you can have fun with magnets, you can experiment so many things, isn't it, so many activities, but you should always treat this magnet with care. Okay, so this was all about magnets that we have learned in this chapter, and I hope you had fun also. If you liked my class, don't forget to hit the like button and share my class with your friends. Okay, share my videos with your friends, and don't forget to subscribe as well. Okay, so we have completed this chapter. Next I'll bring this summary, and yes, in summary you will find, with summary you will also get notes. Okay, as you know, I used to bring summary in little bit detail, where we'll be explaining everything again, isn't it, and that will be helpful in your exam also, which can be used as a quick revision as well, isn't it? So that's all for today. Okay, all of you have a very nice day ahead. Bye.